When you first learn security architecture, it is easy to think of a design as something you create once, review once, and then move on from, like a blueprint that stays correct forever. Real systems do not work that way, because change is constant, and change is exactly how yesterday's secure design becomes tomorrow's risky design. A new feature gets added, a dependency gets updated, an integration partner changes behavior, or a configuration is tweaked to fix a performance issue, and suddenly the security assumptions the architecture relied on are no longer true. Regression thinking is a way of treating change itself as a source of security risk, and it helps you validate that security behaviors still work after something has moved. Instead of asking only whether the new change works, you also ask what might have been broken, weakened, or bypassed by that change. This episode builds a beginner-friendly way to think about regression validation so you can keep a design secure over time, not just on launch day. The goal is to make you comfortable with the idea that security validation is a repeating practice, because systems evolve and the architecture must stay aligned with reality. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Regression thinking comes from the idea of regression testing, which is checking that previously working behaviors still work after changes are made. For security architecture, the focus is not just on any behavior, but on security-critical behaviors that the design depends on, like authentication gates, authorization boundaries, data protection rules, and safe failure handling. The reason this matters is that changes often happen in small, local places, but their effects can be wide because systems are interconnected. A team might update a library that handles input parsing, and that update might change how certain edge cases are processed, which can affect validation, error handling, or even authorization decisions. A team might add a new microservice, and the way it communicates with existing services could introduce a new trust boundary that was never evaluated. Regression thinking teaches you to treat every meaningful change as a question. Which security assumptions could this touch, and what should we revalidate to be confident? You do not need to retest everything every time, but you do need a reliable way to retest the right things. This is how you keep the design's security posture from quietly drifting. A simple starting point is to identify what counts as a regression risk in architecture terms. Changes that alter identity and access paths are high risk, because small differences in authentication or authorization can open serious holes. Changes that alter data flows are also high risk, because they can expose sensitive data to new places or change how data is filtered and stored. Changes that alter dependencies, like frameworks, libraries, or external services, can be high risk because you are importing new behavior you did not write and may not fully control. Changes that alter configuration can be high risk because configuration often determines boundaries, such as which endpoints are exposed, what encryption is used, and what defaults apply. Even changes that seem unrelated to security, like performance tuning or reliability improvements, can affect security behaviors by changing timeouts, caching, or retry logic. Regression thinking is essentially learning to see security consequences in ordinary engineering changes. Once you do, you can design validation steps that keep your security behaviors intact. It is helpful to think in terms of security invariants, which are properties that should remain true even as the system changes. An invariant might be that users can only access their own data, or that privileged actions require stronger authorization, or that sensitive data is never sent over untrusted boundaries without protection. The reason invariants are powerful is that they translate architecture intent into statements you can validate repeatedly. When a change is made, you check whether the invariants still hold, rather than trying to rederive security from scratch each time. Invariants also help you avoid the trap of focusing only on the new feature, because the new feature might accidentally break an invariant in an older part of the system. For example, adding a new reporting endpoint might accidentally bypass the existing authorization logic, even though the endpoint works from a feature standpoint. Regression thinking says you should validate that the invariant about data access still holds for the new endpoint and the old ones. Over time, Your set of invariants becomes a practical map of what security really means for your system. Dependencies deserve special attention because they change frequently and can affect security in surprising ways. A dependency might change how it handles cookies, tokens, redirects, or serialization, and those changes can alter authentication and session behavior. A dependency might introduce a new default that is less strict, such as allowing weaker encryption settings or permissive parsing of inputs. Sometimes a dependency fix introduces a new feature that changes behavior in a way you did not anticipate, like new caching that causes stale authorization decisions to be reused. Regression thinking around dependencies means you treat updates as potential security behavior changes, not just bug fixes. You validate that the system still enforces the same trust boundaries and controls after the update. This does not mean you avoid updates. It means you update responsibly. For a beginner, the key is learning that we updated a library is not a neutral event because it changes the behavior of the overall system, and security depends on behavior. Integration points and external services also create regression risk because you do not fully control them, and they can change out from under you. If your system relies on an external identity provider, changes in token formats, claims, or validation rules can break authentication in subtle ways. If your system integrates with a payment processor or a data feed, changes in API responses or error handling can affect how your system processes data and makes decisions. Even if your own code does not change, a partner change can create new failure modes, such as unexpected null values, new response fields, or different rate limiting. Regression thinking says you should validate that your system handles these changes safely and predictably, especially in failure conditions. A secure architecture expects safe failure, which means when an external service behaves unexpectedly, your system should not default to granting access or exposing data. Instead, it should degrade in a controlled way, such as refusing a sensitive action or limiting output until trust is restored. This is part of validating the design over time, because external dependencies are part of the design. Configuration changes are another major source of regression, and they are often underestimated because configuration can feel like a minor operational detail. In practice, configuration determines how the system is exposed, how it authenticates, what encryption settings it uses, and what logging or monitoring is enabled. A change as simple as opening a network path or enabling a debug mode can significantly weaken security. Regression thinking encourages you to treat configuration as part of the architecture, not an afterthought. That means you validate security invariants after configuration changes, especially changes related to access control, exposure, and data handling. It also means you care about defaults, because many systems ship with safe defaults and then become unsafe when someone changes a setting for convenience. A robust design anticipates that configuration will evolve and provides guardrails, such as least privilege defaults and clear separation between development and production settings. Validation ensures those guardrails still work as the environment changes. To validate design with regression thinking, you need a risk-based approach to selecting what to recheck, because you cannot realistically validate everything after every change. A practical approach is to categorize changes by their likely security impact and then define a minimum set of security behaviors to verify for each category. For example, changes affecting identity and access might trigger revalidation of authentication flows, session termination, and role-based authorization boundaries. Changes affecting data storage or data output might trigger revalidation of data filtering, access control enforcement, and protection of sensitive fields. Changes affecting network exposure might trigger revalidation that only intended endpoints are reachable and that boundaries still exist. This approach is not about lists and bureaucracy. It is about having a consistent habit of rechecking the right things. Regression thinking is a mental model that says changes have ripple effects, so validation must consider those ripples. The more your system relies on complex interactions, the more valuable this habit becomes. Another important regression concept is the idea of security behavior drift, which is when controls still exist but no longer behave consistently. Drift can happen when different teams implement similar features in slightly different ways, or when a new component uses a different authorization library than the old components. Over time, the system becomes uneven, with some paths enforcing controls correctly and others lagging behind. Drift can also happen when patches and workarounds accumulate, and the original design intent becomes hard to see. Regression thinking helps combat drift by repeatedly checking invariants across multiple paths, not just the most recently changed code. If you validate that authorization rules apply consistently across all interfaces, you can catch drift before it becomes a serious exposure. If you validate logging and audit behavior across components, you can catch gaps that reduce accountability. The idea is to keep security behavior uniform and predictable, because unpredictability is often where attackers find openings. Architecture is as much about consistency as it is about individual controls. It is also useful to think about regression in terms of attack paths, not just individual components. An attacker often succeeds by chaining small weaknesses across multiple steps, such as gaining a foothold, escalating privileges, moving laterally, and accessing data. When a change occurs, you should ask whether it affects any step in likely attack paths, such as identity verification, authorization checks, trust boundaries, or monitoring coverage. For example, adding a new internal service might create a new lateral movement opportunity if it is overly trusted and poorly segmented. Updating a dependency might affect input validation and create a new injection path that leads to broader compromise. Changing logging settings might reduce your ability to detect suspicious activity, which increases the chance an attacker can proceed unnoticed. Regression validation can include checking that monitoring still covers key actions and that segmentation boundaries still limit movement. Even for beginners, this mindset is approachable because it follows a simple story. How could someone abuse the system, and did this change make that story easier? You are not required to think like a hacker in detail, but you should think like a defender who cares about chains of failure. One of the most practical outcomes of regression thinking is that it influences how you design systems in the first place. If you know that change is constant, you design for safe change, which means building in clear boundaries, consistent enforcement points, and observable behaviors that are easy to validate. For example, centralized authorization policies reduce the chance that new features implement authorization differently. Standardized logging patterns make it easier to detect drift and validate accountability. Clear separation between public and private interfaces reduces the chance that a new endpoint accidentally becomes exposed. Designing for regression resilience also means avoiding fragile designs where a small change can bypass a control entirely. If a system relies on a single assumption, like this network is trusted, then a small exposure change can break security. Regression thinking pushes you toward layered controls and explicit verification because layered designs tolerate change better. In that sense, regression thinking is not just a testing habit. It is an architectural quality that makes security more durable. As you validate designs over time, the core lesson is that security is not a one-time proof, because proofs expire when assumptions change. Regression thinking gives you a disciplined way to notice when assumptions are likely to be touched and to revalidate the security behaviors that matter most. You focus on invariants like correct authorization, protected data flows, safe failure, and consistent monitoring, and you recheck them whenever changes occur in identity paths, data flows, dependencies, integrations, or configuration. You also watch for drift, where controls become uneven across the system, because unevenness is where risk accumulates quietly. If you adopt this mindset early, you will avoid a lot of frustration later, because you will stop being surprised when updates break security in subtle ways. Instead, you will expect change, design for it, and validate for it, which is how secure architectures stay secure as systems and dependencies evolve.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.